Hi everybody. I'm going to give you a slow demo of some of the infrastructure of our VNC to help you understand what's going on. Some of you have been having some trouble with this. So I'm going to show you my VNC, but know that yours is the same and the robot itself has the same. I don't have a robot here at home, so I can't actually show you what it's like with a robot, but I can show you a lot even here. So you've all seen this a million times. Let me tell you what this prompt means. If it says sim, it means the whole thing is running in simulation mode, which means that it's assuming ROS core and your program is running in the VNC node. If it says real, it's still the VNC node, but now it's talking to a real robot. And if it says on board, now you're actually in the shell on the robot itself. And it's super important for you to keep this straight. I constantly see people getting confused about the two modes because they look so similar. You only get to the robot shell by doing an SSH into the robot. SSH SSH Ubuntu at bullet1.dyn.brandeis.edu would get me onto bullet 1. You have to figure out what the name is of your robot and then do an SSH into it. It'll ask you for a password. It's always capital R, capital O, capital S, little a, little b, no, sorry, ROS Lab 134. So actually like this, ROSLAB 134. That's always the password. So you need to be clear on that because the prompt is going to look the same. Okay, so when you first power up your robot, you have to be on SSH on the robot itself to start the software running on the robot. That's the only way to do it. You have to SSH over to it. You do it once until you reboot the computer, in which case you have to do it again. So there's a whole series of launch files named after your robot. So for example, you might say, and this is not going to work, ROS launch turtlebot3 underscore and then turtlebot3. I don't even remember what. Well, I can actually do it for real. ROS launch turtlebot3 turtlebot bring up, and then you have turtlebot3, and the options. What you want is the core launch or the robot launch, and you can look at them. You know how to read launch files now to see which one you want. If you're working with one of the platforms, it would be ROS launch platform, and it's a slightly different set, but they're similar. You'll recognize them. You want to look for something that's called like bring up all, full bring up, something along those lines. If you look at these launch files, they're all very, very similar. They just turn on different features, and you'll get the hang of it as you go. This step of bringing up the robot has to be done on the robot itself. If you do it on your VNC, it's not going to do anything. So in this case, I would be using either full bring up, which brings up all the bells and whistles, the LiDAR, the camera, and so on. I might bring up camera only, which brings up just the camera on the robot. You have to look at them. Arupo Detect doesn't care what it runs on. It could be run on the robot or in VNC because it's not using the hardware. So that's the notion of the difference between the robot shell and the VNC shell. Two totally different computers, okay? They look alike. You got to keep straight which one you have. You only have to launch on the robot those packages which require access to the hardware, and typically those are just the core package that runs the motors and that gives you the odometry. And then if you want a camera, you have to run one to turn on the camera, which you can tell by the names which one it is. If you want the LiDAR, you have to run one to turn on the LiDAR. And generally something like full bring up or bring up full will turn on all those things. Okay, keep that straight. Now the next thing I want to show you around is how the brew package works. So if you look at, this is the directory, you all have the same directory. Okay. If I look at what I find here, I see, well, a bunch of things. It's different on every computer, but the key things are the same. So there's a bunch of leftover files from playing around at different times. The key things are Catkin WS, which is where all your ROS code lives, and ROS utils. ROS utils you never touch, but you do use it, and it's installed properly on a robot. So you generally don't have to worry about it unless something's not working correctly. The key, and then if you look inside of catkin WS, so I can go see catkin WS, you'll see the usual build, develop, and source. If you go into source, you will see all the top-level packages. In our case, GPG brand contains all this Brandeis software. RPS examples you won't have. Those are my private examples. And PRR examples is the one you have. Okay? And that's where they all live. You know about catkin make, which basically builds everything. But I also want to tell you about CW, which basically does, if you look at the alias CW, you see that it does two things. It's CDs to catkin WS, and then it does this very important step, which makes sure that the environment variables are set up correctly for ROS. Okay, now the real thing I wanted to focus on is the .bashrc file. So we can edit the .bashrc file in many ways. I'm just going to print it for now. It's just a text file. And it's called that because it is automatically, oops, I'm in the wrong directory. So CD, it automatically is run whenever I open a new terminal shell. So let's look at what's here. A lot of it is commented out. So first of all, you can obviously remove this. But then it says I'm running bashrc, and it calls these three source commands, which basically set up ROS. And this is where it calls the setup bash. These two lines set up environment variables called brew_my_my IP, which basically assigns to that variable, if I say echo brew my IP, it'll show the IP address of this particular VNC. Okay? If I ask it what my brew VPN IP is, it's going to be different. Now, why is that? Because every one of our computers, our robots, and our VNCs have two IP addresses. One IP address is the one that it gets from eduroam. Each IP address on eduroam can talk to each other, but because the VNCs are not on eduroam, they have no Wi-Fi. It means that they are not going to be able to see the robots. So what we have is Tailscale, which creates a VPN, virtual private network, where all the IP addresses are compatible with each other. So we're always working with VPN IPs. So these two parameters here, my IP and my VPN, don't touch them. They're correct. They're basically automatically set up. Those are these two lines. These are the important lines. And you notice that I have two versions of them. That's just because I edit them back and forth all the time. So you can go into the nano editor. Again, there's many different ones. And you can look at .bashrc. And let's see what we have here. Well, these are the lines I said you could delete. This is a terrible editor, so I wouldn't spend any time in it. But down here, we're going to see if I'm working with a physical robot, this one is not commented out. It says, and you got to copy this literally and just comment it out or not comment it out. Someday I'll explain to you what this dollar parenthesis business means. But for now, brew mode real sets it in the real mode. By the way, brew is just a Python script that I wrote. It's just trying to automate as much as I can. The next two lines are the ones that are important. There's two lines here, and you need one that looks like that. And basically what it says is this. It says the robot I want to connect to in real life is called, let's say, bullet 1, and its VPN IP is this. So how do I get that? Well, I can get the VPN IP of Rob B, for example, by asking Tailscale status. I can go onto SSH onto Rob B and just do the command my VPN IP there. Somehow I have to find out the IP address of bullet 1 or whatever my robot is. And then I edit this file, brew name, and then the name of your robot, -m, and then the IP of your robot. And so these are the lines, the only lines you really have to mess with. These two are fine, you don't have to touch them. Okay, so when you modify this file and you save it, you can test it by doing source.bashrc, and it basically executes it again, and it sees that it's in real mode. Now you've seen these commands sim and real, but if you do alias sim, you'll see all it's doing is that same command. Alias sim is brew mode sim, and alien real is brew mode real. So if you actually look at alias, there's a whole bunch of aliases that I put in there. You can see in the ROS utils directory, there's a file called common aliens, and that's where I define all of them. So there's a bunch of goodies in there. I don't use most of them, to be honest, but they're there. But the ones that I do use, I'm familiar with. That's where you, for example, find the one that is the teleop one. That's why you can just type the word teleop and it'll do teleop because it's running the turtleplot3 teleop. So when it all said, so the other piece I want to quickly touch on is to just drive home the idea that every robot, every ROS robot needs to be talking to ROS core, but there can be only one ROS core in one group of robots. So if you have your VNC and one robot, or your VNC and two robots, that's 3 computers. Between the 3 of them, one of them is running ROS core. Okay, and what we need is the IP address of the one running ROS core. So if I do printenv grep ROS, you'll see here these 2 lines, which are the most important. These things are set up sorry, not those 2. This one and ROS. Oh yeah, and this one, these 2, ROS IP and ROS master URI. They're set up automatically when you do brew mode real and brew mode sim, so don't worry about it. But if you want to check, this is how you check. And what you want to see is that the VPN IP of your computer, the computer you're on now, is here, and the VPN IP of whatever computer is running ROS core is here. Because I'm in sim mode, actually when I go to sim mode and I do this, you will see that the IP for ROS master URI, this one, is the same as ROS IP. Why? Because it depends on my running ROS on the same computer. You have to, I mean, it's really simple, but it's also a lot of words that sound alike, easy to get confused. You have to take the time to understand it. So don't go hacking away at .bashrc to try to override it. Just take a moment to learn it. Okay, it's quite simple. Anyway, that's basically the background I wanted to give you. I hope this recording came out. I'm going to put it up on YouTube and share it with you guys. Okay, have a good night and see you all tomorrow. Bye-bye.